Have you ever just looked at the universe and felt like maybe there's something missing? Like a missing piece of the puzzle that could explain all the incredible, complex stuff we see all around us. Well, let's dive into that, because some scientists think they are getting really, really close to finding a hidden cosmic rule.
And it all kicks off with this massive puzzle. The universe is, well, it's an incredible builder, right? It makes stars, planets, life, even us. But here's the kicker. One of our most fundamental laws of physics says the exact opposite should be happening. So what gives?
To really get our heads around this, we need to look at a huge contradiction that sits right at the very heart of the cosmos.
So on one side, you have the famous second law of thermodynamics. It's basically the things fall apart rule. It says that disorder, what scientists call entropy, is always supposed to increase over time. But then, on the other hand, just look around. The universe has done the complete opposite. It's gotten way more structured, way more complex, over billions and billions of years.
And you see this entropy thing in action every single day. Your new shoes, they get scuffed. That hot coffee on your desk, it's going to end up at room temperature no matter what. And hey, you can scramble an egg in seconds, but good luck ever trying to unscramble it. That's the universe's default setting, just heading towards a bigger mess.
And yet, this just shows you how deep the contradiction runs. Since the Big Bang, the universe has been on this unstoppable march toward more and more complexity. We went from a formless, hot soup of energy to protons, then atoms, then stars and galaxies, planets, and eventually life itself. That is the absolute opposite of disorder. It's a staggering, incredible increase in order.
So, how do you possibly solve this? Well, a group of scientists has put forward a brand new candidate for a law of nature. It's something they're calling the law of increasing functional information.
Okay, functional information sounds pretty technical, right? But the idea is actually pretty simple. Think of it as a way to measure how usefully complex something is. So imagine you have a million random strings of letters. Most of it is going to be complete gibberish. But that one string that happens to spell out a perfect sonnet, that has super high functional information. It's an incredibly rare, specific arrangement that actually works.
And to give you a sense of the scale here, just think about the elements that form minerals on our planet. The number of ways you could possibly combine them is 10 to the power of 46. That's a 1 with 46 zeros after it. It's a number so vast our brains can't really even picture it. Just an ocean of possibilities.
But get this, out of that absolutely immense sea of possibilities, how many stable, working minerals has nature actually selected? Only about 6,000. That's it. This is a perfect example of functional information in action. The universe didn't bother with all the useless combinations. It selected the tiny, rare fraction of arrangements that actually last.
And what's really cool about this idea is that this selection process, it's not just for biology. The new law argues that this is a universal kind of evolution, one that works on everything from the simplest atoms all the way up to the most complex forms of life and technology.
Turns out, for any system to evolve and get more complex, you just need three things. First, you need a bunch of different building blocks. Second, you need a way to shuffle those blocks around and try new combos. And third, you need some kind of selection, a filter, that favors the arrangements that actually work.
And that selection can take a few different forms. Sometimes it just favors simple stability, like the atoms in a crystal locking into place. Other times, it favors dynamic systems that are constantly working to keep themselves going, like us, like life. And then, every once in a while, it favors a total game changer, like the ability to fly, which just opens up a whole new way of being in the world.
Okay, but proposing a brand new law of nature, especially one that's fundamental, leads us to a much, much deeper question. And it's a question that isn't just about physics anymore. It's about the nature of knowledge itself.
So we've got this really elegant mathematical description for how complexity seems to just pop up everywhere. It's a really compelling idea. But here's the twist. Is this mathematical law something that was already out there, woven into the fabric of reality, and we just found it? Or is it just a clever tool? A language that we invented to make sense of everything?
This is a seriously ancient debate, and it splits some of the smartest thinkers right down the middle, with powerful arguments on both sides. So in the discovered camp, you've got people like the physicist Roger Penrose. The argument is that math is real in and of itself. It exists in its own perfect abstract world. And the physical world follows these mathematical rules so precisely because, well, the rules must have been there first. And the evidence for this is just stunning. Time and time again, some mathematician working on purely abstract stuff with no practical application invents a new kind of math. And then decades or even centuries later, it turns out to be the perfect language to describe how reality works. This unreasonable effectiveness really does make it feel like we're just uncovering a pre-existing blueprint.
But then you have the invented camp. Scientists like Stephen Wolfram argue that the math we use is basically a historical accident. It's a product of our own culture, our own way of thinking. It's not the only math possible, it's just the one we happen to build.
In fact, according to Wolfram's research, the basic logic that underpins all of our mathematics is just one choice out of something like 50,000 other possible, perfectly valid systems. We didn't discover the logic of the universe, we invented a logic that just happens to work pretty well for us.
So, let's bring these two giant ideas back together now. This potential new law of information and the fundamental question of what math even is.
And this brings us right back to where we started. Is this proposed law of increasing functional information a true discovery, a real glimpse into the universe's actual operating system? Or is it a powerful, beautiful invention, a human story we tell ourselves just to organize everything we see?
It all kind of boils down to a question that feels like a classic philosophical riddle. You know, if a tree falls in the forest, well, how about this one? If there's a certain number of trees in a forest, but no one is there to count them, does that number actually exist? Does the law of nature even mean anything in an empty cosmos? The answer might just reveal whether the universe has a hidden blueprint, or if we're the ones making up the rules as we go.